Hello and welcome everyone to today's LeetCode challenge. This is our day 296, and today's LeetCode question number is question 3105, long as strictly increasing or strictly decreasing subarrays. So, we have given an array of integers called nums, and we have to return the longest subarray of nums, which is either strictly increasing or strictly decreasing. Subarray means the contiguous elements of array. So we have to return the longest, either strictly increasing or either strictly decreasing. Means there are no elements in strictly increasing. There are no two adjacent elements in strictly decreasing or in increasing as well that both are equal. So the arrays should be strictly increasing or strictly decreasing. We have given an example. Example number one, 14332. We can see what are the subarrays that can form from this. Uh, the one length subarrays formed from this are 1, 4, 3, 3, and 2. So these are subarrays that have one length. Two length subarrays are 1, 4, 4, 3, 3, 3, and 3, 2. Three lengths of arrays are 143 and 332, 433, and four lengths of arrays are 1433 and 4332, and the final subarray of length 5 is 14332. From all these subarrays, we have to check which array is longest, that is strictly increasing that or strictly decreasing elements in that. We found out that we will find at max of two lengths subarray that is strictly increasing or strictly decreasing. That is 1 comma 4 is a subarray that is of two length and that is strictly increasing. If we add 3 to it, the array is disturbed, and the this subarray is not the strictly increasing array anymore. And we found out that 332 is the longest subarray that is strictly decreasing. But if we add 332 to this strictly non-decreasing subarray, then this array is disturbed because this is not a strictly decreasing because these two elements are equal. So we found out that at most we found two lengths of array from this input, that is strictly increasing or strictly decreasing, so we have to return answer 2. In this we only found that only one element is present in either of strictly increasing or strictly decreasing. If we have add the any other element, then the array is not either strictly increasing nor the either strictly decreasing, so we have to return 1 in this case. And the example number 3 is obviously we can see that this is a strictly decreasing array, and longest subarray in this integer input is of 3 length, that is 3, 2, and 1. This is strictly decreasing, so we have to return 3. So what could be the brute force approach for this, as the constraints are very low, that nums of length is less than equals to 50 only. So we can use the our brute force approach to find out what is the maximum possible answer of either of strictly increasing or of either strictly decreasing array. Let us find out the approach for this. Let us discuss our brute force approach. This is a brute force approach. The code is already written here of brute force approach. This is brute force. And the brute force approach states that first we have to check for increasing subarray what is what is the maximum length for increasing subarray. Strictly increasing, not increasing, it is strictly increasing. And then again we can check for strictly decreasing subarray what is the maximum length possible for strictly decreasing subarrays. And in this given code we initialize our maximum answer to 1 because every element itself is either a strictly increasing or strictly decreasing subarray. So we start our loop for I equals to 0, I less than nums of length. That means for this case I starts from 0 and this will go I less than 5 till I is less than 5. Now uh, I for every I equals to 0, j will start from its preceding its its adjacent index, next adjacent index. Like if I equals to 0, j will start from this. And now this will check if nums of j, that means this 4 is less than equals to its j of minus 1. That means if this is less than equals to its previous adjacent element, the inner loop is broken. That means we are finding the next increasing subarray. So if we found out that nums of j is less than equals to j of minus 1, and here we can see that this condition is not true, so our max is now updated from max. J is pointing to this 1, max is 1, and j is 1 minus 0 plus 1. That means max is now updated to this maximum of these two. That means 2. This will return 2, 1 comma 2. So max is now updated to 2. That means we found out a 2 length strictly increasing subarray. And then again j is updated. So from this, j will now points to this. And again check if j is less than equals to its previous elements. And yes, this time j is less than its previous element, that is 4. So this inner loop is now broken because from this index other elements will not be checked because here the condition for subarray is broken. So this inner loop gets completed, and the outer loop will again check its condition. That means I will now point to this, and our maximum will contain answer as 2. I will now starts from here, and again j will starts from its next index. Now j will starts from here and check if this is less than equals to its previous element. Yes, this 3 is obviously less than 4. So again this loop is broken. So now j will and I will again incremented by 1. So now I moves to the index 2, and this time j will starts from its next element, that means from here. And this time this will again check if this index is less than equals to its previous. Here we can find out that this 3 is equals to, less than, and equals to. So this satisfies the condition equals to. So again this J loop will discarded and I is again incremented. Now I is pointing here, and the J will start from its next adjacent index. J will now starts from this index 4, and this will again check if this nums of J, that means 2, is less than equals to its previous element. Yes, it is less than equals to its previous element, so the condition is true and this inner loop is now again broken, and I is now incremented. So I will go to this, and again J is now points to this, and if J pointing to this position will check whether J is within the limit of this array size. So this for loop will never executes, and our answer for this part remains as 2. That means we found an increasing, strictly increasing subarray of length 2. And now the answer for strictly decreasing subarrays will checked. That means we have to find out that whether in this input there is any subarray strictly decreasing and which has the maximum length greater than this 2. So again this I will start from here, I equals to 0, and this outer loop will check if this I is within the limit range of this size array size. Yes, it is within the limit range of this array size, and the inner loop will execute it, and J is initialized to its adjacent index, that means here. And this time we were checking for the strictly decreasing subarray. Is there any subarray in this input that is strictly decreasing and which has the greater length than the our previous subarray, which has 2 maximum length possible. Now again check if nums of J is greater than equals to nums of J minus 1. Here we found out that nums of J, that means this 4 is greater than our previous, so this J loop will broken and I is incremented. So I will now points to this, and J is now starts from its adjacent index, that means here, and this will check if J is less than equals, if nums of J is greater than equals to its previous. No, here we found out that nums of J is not greater than or equals to its previous, so this if will not executed, and max is now updated to max as of previous value what max hold, that is 2, and J minus I plus 1, that means 2 comma J is 2, I is 1 plus 1. Maximum of this, and maximum of this 2 comma 2, that is 2 only. So again max will contain a value 2 as the maximum subarray length, that is either strictly decreasing or strictly increasing. Now j is again incremented. J will now points to this, and now j again check if nums of j, that means this, is greater than equals to its previous element. And we found out that this nums of j is equals to its previous element, so this inner loop is now broken. So this inner j loop is now broken, and our I is again incremented. I will now points to this point, and j will start from its next adjacent index, that means here, and this will check if this nums of j is greater than equals to its previous element. Yes, it is equals to its previous element. Then again j loop will again broken and I is again incremented. So I will goes to this, and j will now points to this, and at this time this will check if nums of j is greater than equals to its previous element, that is is this 2 is greater than equals to its previous, that is 3. No, this is not true. So our max is now updated from its previous value. The previous value that max hold is 2. So max is now updated to its previous value 2. J is 4, and 4 minus 3 plus 1, and the maximum of this is 2 as well. So max will finally contains a value 2, and we will return 2 as the answer to caller. So this is a simple brute force approach, and this simple brute force approach will take as a time complexity of big of n square, and a space complexity of big of 1. But we can have a better solution than this approach, in which we can reduce our time complexity to big of n, and the space complexity is then obviously increases to big of n as well, but the time complexity is drastically reduced in that approach. So let us see our second approach for this. Here we we are declaring two arrays of n size, which are firstly initialized by 1 1 as answer, 1 1 1 and 1. The name of these two arrays are, that is one array is in or increasing subarray, and the other is decreasing subarray. The idea for this approach is very simple. Idea for this approach is what is the maximum answer possible for the increasing subarray till index I, or what is the maximum answer possible for the decreasing subarray till I index. And we initialize our increasing or decreasing to 1 because of the fact that each and every element in itself is either a decreasing subarray, strictly decreasing subarray, or it is a strictly increasing array. So we initialize our this both arrays, increasing subarray or decreasing subarray, by 1, and now we will start our I equals to 1. That means we start our loop from this point here, and we will check if this nums of I is greater than its previous elements. Yes, it is greater than its previous elements. That means this this is a strictly increasing subarray. So for I equals to 1, we found out a strictly increasing subarray. So we have to increment our increasing of I to its previous plus 1. That is, uh, for I equals to 0, this is an increasing subarray, and at I equals to t, I equals to 1, we found out that this is also a part of increasing subarray. So we incremented our I increasing of 1 to its previous plus 1, that means 2. So this will indicates that at I equals to 1, we found out a two length maximum of two length increasing subarray. And again we will check if nums of I is less than nums of I minus 1. So this is not less than to its previous. So we will not update our decreasing subarray, and I is now incremented. So this here I goes to this, and this will check if this is increasing to its previous elements. No, this is not increasing to its previous element, but this is decreasing to its previous element. So we will update our decreasing part this time. That means this index is now updated from its previous value plus 1, that means 2. And this 2 will indicate that at index I we will found out a maximum of 2 length subarray that is strictly decreasing. And again the I is incremented, and we find out that this is not greater than it to its previous elements, and this is not less than to its previous element is as well. So this will not updated any of the increasing or decreasing subarray. And now I will points to the last index, and this will check if this is greater than to its previous element, which is absolutely not correct. And again this if condition will check if this is less than to its previous elements. Yes, it is less than to its previous elements. So this decreasing subarrays index is now updated to its previous plus 1, that means 1 plus 1, that means 2. And now we will found that at most there are two length subarray, either that is strictly increasing or decreasing, and that is our answer. So we will initialize a variable answer 0, that means answer will contain 0, and we will now check what is the maximum possible value in both these arrays is possible. We will start a loop for I equals to 0 and update our answer as maximum of answer and increasing of I. That means maximum of 0 and 1. Now this will update it to 1, and again this will check maximum of answer and decreasing of I. That means maximum of 1 and decreasing of I, that means 1. So this will received as 1, and again I will update it to this, and answer is updated to 2, and similarly like that our answer for the final index was also 2, and finally we have to return as 2 for this input. So this is a slightly better approach than the previous one, which is big of n time complexity, and this will also take big of n space complexity as well. But this approach is slightly better than the previous, as constraints are very low. We can try out big of n square approach as well. That will also run fine, but big of n approach is always better to use. So let us code this and found out that is it running fine or not. Decreasing name and initialize is 1. Let us run our loop from I equals to 1 and I equals to less than n. Check for both subarrays, either it is strictly increasing or strictly decreasing. Either that number contributes in strictly increasing part or strictly decreasing part. And if that number is not contributing in any of the part, then we have to do nothing. Now initialize our answer as 0 and let us check what is the maximum possible value present in both these arrays. Update our answer and finally return our answer. Now let us run this and find is it running fine or not. Yes, it is running fine. So let us submit this. Yes, this is running fine and this will beat 100% of users with 0 ms runtime. And so this will conclude our day 297, and thank you so much guys for seeing this video and keep supporting and do like and subscribe to our channel. Thank you.